One example of this that I see a lot in code bases, unfortunately, is people using divs instead of buttons. And I think this is because the button element applies its own default CSS, which is kind of ugly. And so they have to like undo the CSS to probably style it the way they want. So they're like, okay, I'll just use a div because it looks the way I want and I can just apply an on-click handler to it. Semantic HTML include elements that assign a role or meaning to the content that it encapsulates. Using these elements makes their purpose or intention clear. Some examples of semantic elements include header, figure, and even the button tag. This is in contrast to generic, non-semantic elements like the div and span tags. Simply put, if you use the right element for the job, you get accessibility gains baked in for free. Use native elements whenever possible. Trying to build your own is always more work because you have to ensure that the accessibility meets the ARIA standards. And one example of this that I see a lot in code bases, unfortunately, is people using divs instead of buttons. And I think this is because the button element applies its own default CSS, which is kind of ugly. And so they have to like undo the CSS to probably style it the way they want. So they're like, okay, I'll just use a div because it looks the way I want and I can just apply an on-click handler to it. But even though the button action may work on a div like it does on a button, you lose all the accessibility gains because you're using a non-semantic element. So things like focus, being able to tab, pressing space or enter to activate, it won't work because you're using a generic div element. So that's just an example of a major culprit that I kind of see a lot in code bases. So yeah, always use the right element for the job because you get accessibility gains for free. And even if it's more work to undo CSS, it's always worth it because the accessibility gains you get make it worthwhile. Technical affordances are the perceptions of interactions one can take with a piece of technology or software. This term can be applied to both the physical and digital realms. It's a term coined by psychologist James Gibson when interacting with an item. Obtaining identifiable affordances improves usability by making interacting with common pieces of software more intuitive. And some common examples of tech affordances are a hamburger menu that you see a lot in mobile views. It's usually a condensed navigational menu and represents hidden navigational contents. There's also the common link, which indicates that it will direct you to a different web page or link within that website. And then, of course, a button that indicates that it will perform an action. Now we'll take a look at headings. In HTML, there are different levels of heading elements ranging from H1 to H6. HTML headings provide a clear structure and hierarchy to the information presented, making it easier for all users to navigate and identify the structure of the content. The order in which a screen reader interprets content is based on the DOM order, and having proper headings makes it easier for screen readers to maneuver through a website and provides a proper hierarchy of content. When a web page is structured in an easy-to-follow hierarchy, screen readers and keyboard users can identify the main section and navigate more quickly through the document. So if we scroll down on this website, we'll see that there is an example of the different headings and how they're styled. And so by default, heading level 1 is kind of the biggest font size and the boldest, and all that kind of gets incrementally smaller and less bold as you go down to heading level 6. And if we go to this W3C page, we can actually click this button that says Show Headings, and we can kind of see the heading layout on just this sample site here and how you would potentially lay out a heading hierarchy on a website. So now I want to discuss some tips for using headings. And the first is to not use headings as a styling technique for text. Instead, use the font size property if you want to make alterations. So let's say we have a kitten card example here where we're trying to show a cute kitten that's available for adoption. That is my cat Snickers, by the way. Let's say we have that kitten for adoption, but the text is just too small. We want it to be bigger. Don't go ahead and make that an H1. Let's say, because typically articles are going to be somewhere nested on the page, so the H1 seemingly would have been higher up. So we want the H3 tag because that's the semantic heading that we want and maintains a proper hierarchy, but we don't want like the style. So instead of changing the heading tag and messing with that hierarchy, we can instead apply the font size property to the H3 in the CSS and just make it larger. And then that way we can get the styling that we want and still maintain the proper heading hierarchy. This topic we'll discuss are landmarks. Some common landmark elements include the main, nav, and section. By default, a majority of these elements have an implicit ARIA role associated with them. And a lot of landmark elements are actually semantic elements. Landmarks ensure content is in navigable regions, which, like the heading tags users mentioned above, make it quicker for screen readers and keyboard users to maneuver through the content swiftly. In addition to having accessibility benefits, landmarks make it so that a scan of the HTML conveys the desired hierarchical structure of the document. So let's maneuver over to the W3C page, which we looked at earlier to demonstrate our headings, and let's toggle the Show Landmarks button instead. And at the top, we can see that we have a banner, we have a navigation, we also have a navigation on the left-hand side. In the center content, we have our main tag, which typically encapsulates a majority of the information, hence the name main. On the right-hand side, we have two complementary blocks. And if we scroll down, we see we have like a footer here, which has an implicit ARIA role of content info. So this is just a simple example of how a website might be outlined using landmark elements. The alt attribute is intended to contain a description of the associated image. This attribute greatly enhances accessibility by allowing screen readers to vocalize the provided text, enabling users to understand the meaning conveyed by the displayed image. Additionally, alt text is also displayed when an image fails to load for various reasons. Without the alt text, you would see a broken image and have no context of what should have been rendered. Most screen readers would react to this by reading out the file name, which is usually a long and verbose string that isn't very descriptive. This is just a simple example of how alt text benefits users of all abilities. So let's actually take a look at alt text in the wild, so to speak. And so let's go to the ARIA Authoring Practice Guide website. We're on their homepage here, and let's inspect one of their images. And we can see that the alt text for the image is right there. There's a string for it. And let's inspect a second image and take a look at that alt text and how it kind of differs. And what I want to do is I actually want to intentionally break one of these images so that you can see what is rendered when the image can't display for some reason. So go ahead and modify the URL and notice that it says now indicators delve inside a document. And that's the alt text that's provided. And so even though the image isn't displayed, we kind of get an idea of like, okay, this is what this image would have represented had it actually been rendered properly. And so let's go to that other image and do the same thing. We're going to break the link, but instead I'm going to intentionally remove the alt attribute entirely because I want you to see what happens when you don't have alt text. And when we do that, notice that we get nothing that's displayed. It's just, nothing. We have no context of what should have been rendered there in its place. And so that's not helpful for screen readers or assistive technology because they have no idea. It just would say like image or read out like a long verbose file name, like I said earlier. And then for sighted users, we also have no idea what should have been displayed there. So there's just kind of an example of how defining the alt attribute is very helpful to people who use assistive technology and those who don't. Crafting alt text can be nuanced. Try to avoid descriptions that are too lengthy or wordy, and aim for clear, concise, and succinct depictions. The second is that choosing whether an image is decorative versus informative can be nuanced, and is ultimately up to the discretion of the author. Third is to avoid using terms like image, picture, or icon within your alt text, as it becomes redundant since screen readers already announce that the element being narrated is an image. Labels and inputs go together like two peas in a pod, as the two elements typically need to be used in conjunction with one another. Inputs play a crucial role in gathering information and are ubiquitous throughout the web. For example, like the contact form that you see here. Equally important, labels provide context and guidance for the associated input. Inputs that rely solely on attributes like placeholder text or icons to convey their purpose exclude users who rely on assistive technology. When labels and inputs are properly associated, they offer significant accessibility advantages, including convenient interaction. So when you associate a label with an input, It allows users to simply click on the label to interact with the corresponding input. The expanded target area for input focus offers a benefit to all users, including those utilizing touchscreen devices, as it facilitates easier interaction of the input element. There's also enhanced screen reader support. Correctly associating labels with inputs ensures that screen readers announce the label when the associated input receives focus. This provides users with clear and contextual information about the purpose and function of the input.
Required edit text article. Last name star. Required edit.
And as you can see, the screen reader is reading out the labels here for the contact form.
Required menu pop-up. Message star. Required edit text. Voiceover off.
Now we'll go through some examples of the two different ways to associate a label with an input. The first approach is what we call explicit association. And to achieve this, you need to do two steps. The first is assign an ID attribute to the input element. In this case, we'll add an ID with the value of email-address. Second, you need to apply the for attribute of the label element, ensuring that the value of the for attribute matches the ID value of the corresponding input element. So on the label here, we'll add a for attribute and give it the same value that we gave it to the ID, which was email-address. Alternatively, you can nest the input elements directly within the label tag. When this approach is used, the for and ID attributes are no longer required as the association is implicit. As you see here, we'll add a new label, and this time we'll add an input with a type of checkbox, and we'll just nest that input within the label, forming that implicit association. Now we'll take a look at an accessible, friendly way of hiding a label. Occasionally, you may want the ability to hide a label. For example, in certain situations where the purpose of the content may be evident from the visual context. While the label can technically be visually hidden, we have to ensure that we think about this from an accessibility standpoint so that individuals using assistive technology are taken into consideration and have a comfortable user experience. Although there are one-line styles like display none and visibility hidden, which will achieve the desired visual effect, this is not suitable for screen reader users. A commonly employed technique uses CSS to keep the information accessible to assistive technology, but visually hidden. This approach presents the label within a 1x1 pixel area, as shown in the example using the CSS class visually hidden. So we would just add a class called visually hidden, like I said, and then we would take that class and apply it to the respective label element. So in this case, we'll apply it to the first label element for email address. And if you notice when we do that, the label gets removed from the UI. And when you apply this technique properly, you still include the label element in the HTML. You just apply the class, and then that removes it from the DOM. And we'll see. So if we take a look and actually inspect this input, you'll notice that the label is still in the DOM, right? The class are just being applied to it. And if you look at the accessibility tree, it still notices that the email address label is there, which is exactly what we want. And if we take a look at MDN itself, they are employing the same technique with their search input. They have a label, they have a class called visually hidden, just like we do. The label is search MDN, but you don't see it, but it's still accessible to the accessibility tree. Again, this is a very common technique that's used. Ensuring appropriate color contrast is key to providing a comfortable and comprehensible reading experience for users interacting with the content on your page. Color contrast is a measurement of the perceived difference in brightness between two colors. This brightness difference is expressed as a ratio ranging from 1 to 1. Achieving the appropriate color contrast ratio enhances the legibility of content. Fortunately, there are numerous tools available to assist in verifying the contrast ratio between colors. One such tool is the WebAIM Contrast Checker, where you can input the foreground and background colors to determine if they meet the different levels of WCAG conformance. And as you can see here, it shows you the conformance levels of both AA and AAA, along with graphical objects and UI interface components. So in this case, what it looks like for like the border of a text input. There's also an explanation giving you details about, what the contrast ratio requirements are based on the level of conformance you're trying to meet, and also a little bit of verbiage around what's considered large text versus normal text. So some nice metadata there to help you kind of decide what ratio you're looking to achieve. And there's also a contrast trigger API and bookmarklet if you're interested in that too, which is kind of neat. So let's see, there's also a slider. So here's an example where I'm going to intentionally slide things down so that make it so that the contrast is really, really low and not visible. And then you can slide it up and it shows you the ratio in real time, updates. Same thing with the background color. You can do that. So it's a really nifty tool. It's one I personally like to use, but there are myriads of them out there. So if this one doesn't suit your fancy, you can do a quick Google search and find a contrast checker tool that you like. Applying appropriate color contrast is crucial in multiple aspects of a user interface, starting with the background color and text color of a page and extending to other elements like buttons and label text. So I found this image from the 4 Kitchens Accessibility As You Go article that conveys a difference in contrast ratios in a good way. As you can see, this first button shows you one that fails both AA and AAA conformance, along with the second one there, giving you a better ratio, but still fails both levels of conformance. This third button here passes AA conformance, but fails AAA. And then the fourth button, same thing, passes AA, fails AAA. And then the fifth button passes both levels of conformance. And then that last button just shows you kind of what the top contrast is versus the bottom contrast and kind of the levels that pass there. So it's just a cool image that I found that I thought kind of conveyed how contrast ratio can be captured, on just regular elements that we use in day to day. According to the Colorblind Awareness Organization, there are estimated to be approximately 300 million people with color blindness. This breaks down to roughly 1 in 12 men and 1 in 200 women who have some form of color deficiency. The WebAIM checklist item 1.4.1, use of color, states the following: that color should not be used as the sole method of conveying content or distinguishing visual elements. And then the second bullet point goes on to say how color alone should not be used to distinguish links, and providing more context there of how it should be used. And so if you look at the Colorblind Awareness site, actually, they have an interesting slider here that you can kind of play around with. And they split it up between the two different types of color blindness. So this first type with this tritanopia, if you go and slide it, you can kind of see, how the grays come out more and what a person who has that type of color blindness might see the world. And then the other type with deuteranopia, also showing how that, look how the pink completely goes to gray. So it really gives you some context for kind of how the varying types of color blindness can affect what people see in the hues of color. And one way to remedy not solely relying on color is to provide multiple avenues for the user of your site to access critical information. So if we take a look at Table UI's input with validation error example here, you can see that they make the border of the text input red to indicate an error. However, in addition to using color, there is an error message indicating what went wrong, along with an icon that we see typically associated with invalid states. So those 3 things combined, right? The use of red color, the message describing why the input is invalid, and the error icon, and it is an example of not relying on color alone to convey information. Now we'll go on to styling states for interactive elements. By applying targeted CSS to the different states of interactive HTML elements, for example, links, buttons, form inputs, we can enhance accessibility and improve the user experience. The states we'll cover in this lesson include hover, focus, and disabled. Customizing these states with appropriate visual indicators ensures that users can easily identify interactive elements, navigate through the interface, and perceive changes in element states. So the first one we'll take a look at is hover. And to apply hover styles to an element, you can utilize the hover pseudo class. By adding hover styles, you can create interactive and engaging effects, such as changing the color, size, or background of an element. And so for this example, I've applied hover to the button. And as you can see, it goes from the white background to the blue background, and then the white text on the hover. And you also want to make sure when you're implementing these effects that you're still meeting contrast ratio requirements. Next, we'll take a look at focus. Each browser applies its own default focus styles, often represented by a blue border surrounding the focused element. These default styles are especially important for keyboard users, as it makes it visually apparent which element is currently receiving focus as a user is tapping through the page. However, sometimes you want to be able to style this better to suit your design. To achieve this, you can leverage the focus pseudo class and the outline CSS property. The focus pseudoclass is typically activated when a user interacts with an element by clicking, tapping, or selecting it using the tab key. The outline property is used to create a visible outline around an element, and targeting this property allows you to alter the appearance of the focus ring. Setting outline 0 or none should be avoided as it completely removes the focus indicator and prevents users from knowing which element they're interacting with. If you're going to remove the focus ring, you need to replace it with an alternative focus indicator so that it is still easy to discern which element has focus. So here's an example where I've applied focus to a link, and I've called it smashing link because it's intended to emulate the smashing magazine focus indicator. So as you can see, when I tab to it, it adds the little dash border around it. And when you click on the link, I'll actually show you, going to the Smashing Magazine website, kind of how they've employed this and how I kind of took their CSS and applied it to this example. So just a fun one here. An element is considered disabled when it cannot be interacted with, such as being unable to be selected, clicked on, typed into, or receive focus. To style elements that are disabled, you can target the disabled pseudoclass. From there, you can select the desired element using its appropriate selector and define the styles you want to apply, such as adjusting color, opacity, cursor, or any other visual properties. In this case, I've just applied a cursor not allowed, a common thing that you see with disabled elements, and kind of made it this gray background. Again, making sure I adhere to color contrast ratio requirements. And so it just makes it very apparent that, you can't click on this button. It doesn't do anything. Yeah, just kind of common techniques to employ. And so one technique that can be used to properly style custom components you build is to target the ARIA attribute that is being applied and style it with the CSS attribute selectors. By leveraging ARIA attributes such as ARIA disabled or ARIA invalid, you can apply custom styles to elements that possess these attributes, enhancing the visual representation and end-user experience for individuals who rely on assistive technologies. For example, to style an input that contains an error, you could use the attribute selector ARIA invalid equals true and apply appropriate styles to visually indicate that the input contains invalid content. And that's exactly what I've done here, kind of imitating that Tailwind UI input validation error image I showed you earlier. I've just added an ARIA invalid to true and make it so that the color and outline color are kind of this maroonish hue. And if you remember the POUR acronym, the O in that acronym stands for operable. And it represents a principle that emphasizes the usability of UI components and content navigation, ensuring that all interactive HTML elements such as links, buttons, and form inputs, for example, are not only functional with a mouse, but also fully operable via a keyboard. Although focus can be activated via mouse interaction, focus management is especially critical for users who rely predominantly on the keyboard to move around a web page. The next topic I want us to discuss is tab order, which, as the name implies, determines the sequence in which focus moves through a web page's interface. Ensuring a logical and intuitive tab order is crucial, where the visual arrangement of elements accurately reflects the actual tab order. By default, HTML elements that are intended for user interaction are implicitly focusable. These elements are automatically included in the tab order for seamless navigation. Conversely, elements like images, paragraphs, and headers are intentionally excluded from the tab order. This design choice ensures that focus is specifically directed towards elements that users can actively engage with, maintaining a practical and efficient user experience. And one way I wanted to convey this concept is by going to the contact page on my podcast website. And I wanted to come here because there's a lot of interactive elements and it's a simple page. And if I open up the DevTools in Firefox and go to the Accessibility tab, there is a Show Tabbing Order checkbox that you can check. And if I check that, it will show us the natural tab order for this website. And so if we see here, the first item in the tab order is the kind of the left panel here. And then next are all the interactive elements within the contact form. So we see we have first name, last name, and then it kind of goes in chronological order there based on the interactive elements. And intentionally, the non-interactive elements like the contact us header and the paragraph underneath that are not in the natural tab order because you can't interact with them. So just wanted to give you guys a visual example of kind of how that looks like on a web page. The one thing to take caution on is if you're trying to alter the tab order with CSS. For example, when reordering flex items using the order property, as assistive technologies like screen readers cannot access the correct reading order. The next topic I want us to discuss is tab index. For situations where you want to modify the tab order, you can leverage the tab index attribute. Tab index can be applied to any HTML element and accepts a range of numeric values. An element that includes the tab index attribute with a valid integer value can receive focus through JavaScript using the focus method, or visual interaction by clicking with the mouse. A tab index with a negative value is most commonly used with tab index equals -1, but the specific value is insignificant. When the tab index value is negative, it removes the element from the regular tab order, rendering it inaccessible via the keyboard. However, the element can still receive focus by manually clicking on it. A tab index with a value of 0 allows an HTML element to be included in the default keyboard navigation order. When an element has tab index equals 0, it can receive focus through the tab key or programmatically invoking the focus method. Applying a 0 tab index enables elements that are not inherently focusable to become accessible for keyboard users. Using a positive tab index value is not recommended and should be avoided. When an element has a tab index value greater than 0, it would be placed at the forefront of the tab order regardless of its position in the DOM. This can lead to confusion for screen readers and potentially disrupt the expected tab flow. If there is a need to adjust the tab order in this way, the recommended approach is to reposition the element higher in the DOM. Let's take a look at an example to really understand the concept of tab index. And if you scroll up to the top of the page, we'll see that MDN gives us a nice example that we can play around with. And if I click in the window here and press tab, the first item that gets focus is that input element at the top. If I press this tab the second time, the second item that receives focus is now that div after the input because it has that tab index of 0 being applied to it. And if I press tab a third time, the bottom input now receives focus. So let's tweak some of these tab index attributes values to kind of see what result we get. And the first thing I want to do is apply a tab index of -1 to the first input element. If you remember, input elements are interactive elements and therefore are implicitly focusable. So by applying a tab index of -1, I am now removing that from the natural tab order. So when I apply that and then press tab the first time, now you see that it skips over that first input and actually goes to that first div instead. And if I was to press tab again, it would go back to the next input. So let's go ahead and revert that and put it back in its natural state where there's no tab index. And the next thing I want to tweak is removing the tab index attribute from the div. Divs are not interactive elements and therefore by default are not implicitly focusable. So by removing that tab index equals 0, we're now putting it back into its default state, so to speak. And so now if I go in and tab through this window, the first item that receives focus will be the input element at the top. If I press tab a second time, we will now skip over those two divs because they're not focusable, and it will go down to the bottom input. So the last technique we'll talk about is roving tab index, which is a focus technique that involves assigning tab index -1 to all children elements while setting tab index 0 on the active item. The corresponding code for this technique includes a keyboard event listener that responds to arrow key presses. It dynamically adjusts the tab index values of the following items to tab index 0, triggers our focus method, and ensures that the previously focused element has its tab index -1 set. Upon reaching the last element in the list, the focus will wrap back around to the first item, creating a circular navigation flow. Similarly, when the first element is reached, it will return to the last item, ensuring seamless navigation within the list. Roving tab index is a technique that we will actually implement later on in this course in the interactive section. But for now, I want to show you an example by going to the APG website and looking at their toolbar example. If we tab into the toolbar component here that they have, if I press the right arrow key and say iterate through each item in this toolbar component, when I reach the end of this list and I press the right arrow key again, it will loop me back to the first item, which is that B button. And if I was to say reverse back and press the left arrow key and go backwards, and when I reach the first item, it will take me back to the last item in this list. So roving tab index is just kind of a nice way to have this circular navigation flow, the seamless flow that when you reach the last item in the list, it takes you back to either the front or the back of the list, depending on where you are.
If you want to keep learning about how to build real-world apps with the latest technologies and other career-related topics, Then start right now by subscribing to our channel and liking this video.